Hello guys, so today we'll be answering this Newton's second law of motion problem, and I hope it will be extremely helpful to you guys. So remember to go check on my bio. We have a website where you guys gonna request that we apply for universities, colleges, and bursaries. So just go there right now and just check out what is actually going on. Okay, let's actually start answering this question. Now it says um, a block of mass 50 kg on a horizontal surface ABC is connected to another block of mass 100 kg on a frictionless surface CD at 30 degrees to the horizontal with a light inexorable string that runs over a light frictional pulley um, as shown the horizontal section A. Okay. What I realize is that this section AB actually has friction, but the section C and D doesn't have friction, right? I feel like this one it's more accurate. That's what they were actually stating here, that BC is smooth, AB is rough, AB is rough. What about CD? I believe that also CD is also smooth, right? Okay, now they say the 100 kg block is pulled up by means of a constant 600 Newton force, right? So this is the constant 600 Newton force. And they say, okay, the two blocks move at a constant speed. What do we know about constant speed? We know that whenever we hear the term constant speed, it means that F net eventually equals to 0, right? It means that F net eventually equals to 0. Now let's actually start to answer this question. Now the first question is draw a free body diagram of the 100 kg block. So let's look at the 100 kg block and try to draw the free body diagram of it. Well, the first thing that we notice is we're gonna have the force applied, and then we're gonna have the tension force, right? And we're gonna have the normal force and Fg, all right? But do not dispute that we have got Fg parallel and Fg perpendicular, but when we draw a free body diagram, for some reason we do not include them. Okay, the second question says calculate the coefficient of kinetic friction at AB, right? They say calculate the coefficient of kinetic friction at AB. Well, we know that that is actually identified by the formula. Okay, so this is the formula that we use. Kinetic friction equals to the coefficient of kinetic friction times the normal force. Well, what is the frictional force at this point AB? Let's actually look at the question and see if we were actually given that value. Let's actually look at that question and see if we are being given that value, because I literally don't remember a point where they actually gave us the value of the kinetic frictional force. Well, it seems like they did not give us frictional force. But what do? You do not panic, right? You don't panic, because if you actually come to point AB, you know that if you draw the free body diagram of this 50 kg block, you're gonna have tension, and then you're gonna have friction, right? And then you're going to have Fg and the normal force. So it means that F net equals to 0, because it is under what? Constant speed, right? And then so if we want to dispute this within the formula, tension is on the positive side is going to be positive, and friction is on the negative side is going to be negative friction. That actually equals to 0. So we now start to understand that, okay, the tension actually equals to frictional force. Tension actually equals to frictional force. right? So how can we actually use this information towards our advantage, right? Okay, so how can we actually find the tension to actually answer this problem? Well, now let me just come into this new paper. Well, we're gonna start here for the 100 kg block. So we know that on the 100 kg block, our F net actually equals to 0, right? So if we actually refer to this free body diagram, we realize that we're gonna have the force applied, right? We're gonna have the force applied, and again, we're gonna have the tension force, right? And again, we're going to have mg, the sine of theta. This is the FG parallel, and all of this is going to equals to 0 because this thing is under constant speed. If you want to understand more about the MG parallel and the MG what, you can just enroll on our course. I just want to make this video a little bit short, so I don't want to dive into that. It will make the video longer. So the force applied is actually 600, and the tension force is what I'm looking for, and the mass is 100, and gravity is always 9.8, the sine, and you can see that my theta is actually 30 degrees, and this is actually going to equals to 0. So I'm going to hit my calculator to find the value of all of this. So 600 minus 100 times 9.8, the sine of 30, I actually get negative tension plus 110, that equals to 0. So I'm just going to take this into the other side. I'm going to have minus T equals to minus 100, 110. So it means that the tension equals to 110 newtons, right? So the tension actually equals to 110 newtons. Well, okay, if the tension equals to 110 newton, well, I actually have, do you remember what we have done? I actually have got this telling me that, okay, but the tension equals to Fk for this block, right? The tension actually equals to Fk. So it means that, therefore, this tension, it also equals to what? To the Fk. So it means that also the value of the friction is also going to be, why am I saying 100? It's 110 newtons. Right? And then now I know that I'm going to use this formula. I'm trying to find this. Remember the question said, calculate the coefficient of the kinetic friction, right? So I now know that Fk equals to 110 equals to mu k. What is the value of the normal force? Well, the normal force is given by mg, and we know that the m here is 50. So I'm just going to say 50, and the g is going to be 9.8. So if I divide both sides by this, what am I going to get? Let me hit my calculator. I'm going to get 110 50 times 9.8. That is actually going to be 0.22. It doesn't have the SI units because they actually cancel out. Okay. This was a tricky question if you don't know your basics too much. If you did not enroll into our course, it's completely understandable why that should have freaking you out. But to those guys who have joined our course, who have dealt with this, to them it's just, it's like drinking water. Okay, let's go into another question. They say, what is this question saying? After a moment, the 50 kg block passes point B. It now passes point B. Remember, this is frictionless free. This is friction free, right? It passes point B, and the constant 600 Newton force continues to pull the 100 kg block up the inclined surface parallel to the surface. Calculate the magnitude of the acceleration of the block, right? So in another word, they are trying to tell us that this thing is now no longer under constant acceleration. This thing is now no longer under the what? The constant acceleration. So how do we do that? This thing is now, it is no longer under constant acceleration. So we're going to come back to this one. Well, we now know it is still going to have force applied. we're still going to have tension, and we're still going to have mg, the sine of theta. But this thing now equals to ma because it is no longer going under constant speed, right? So the force applied is still 600. Okay, let me just say minus T, because we no longer have friction, the magnitude of tension might have changed, right? And then minus the value of m, it's 100 times 9.8, the sine of 30 degrees, and mass, it's 100 and a, right? So let me just hit this inside the calculator. 600 minus 100 times 9.8, the sine of 30. Okay, I was just confirming if it's still 110, that equals to what? To 100a. So let me just make t subject of the equation. So I'm going to take this t to the other side. It's going to be a positive, equals to 110, and then I'm going to take this into the other side. It will be minus 100a, right? And then let me go to this one. This one, I know it's going to be tension, that equals to ma, because there's no longer friction, right? There's no longer friction. Well, I will say T minus F. There's no longer friction. It's just T equals to ma, and T and M is going to equals to 50, and then A. So now both sides equals to T. So I'm going to have 110 minus 100A equals to 50A. So 110 equals to this is going to be 150A. So I'm going to divide both sides by 150, right? So I'm going to divide both sides by 150, and then I get that my acceleration actually equals to 0.73 meters per second squared. So that's how you actually answer this question. Well, for more videos like this, try to follow me, and we're trying to get almost all the learners in the country to know Marvel Tutor so that they can actually get help from us. We're extremely useful and helpful, if I may say. Anyone that watches our videos, but most importantly enroll into our courses, you are guaranteed that you're gonna get an 80% and above on your final examination. So share the news with your classmate. Please don't stay with the information so you can pass alone. Just also tell your classmates, and also tell your other friends from other schools, and share our videos, like, comment, and repost our videos so that more people can actually see this. Otherwise, guys, enjoy the rest of your day.